Okay, this is the Math 1 study guide video for the Semester 1 final. If you're one of my students, I want you to copy all this work and the 10 secret words to show me that you listen. And then every once in a while, I'll have you do an extra problem to show me true learning. But here we go. First problem has you plug in a value into X, but I want you to show the work using this function notation. Take that f of X and show me that you're replacing that X with -5. Show me that. Show me that the -5 is going right in here for X, and then I'm going to do the work using my calculator or not. That gives me the function when X is -5 is -20 minus 6, know the rules for timesing, and then know the rules for adding and subtracting. This gives me not positive, -26. And that's telling me, again, when X is -5, the Y number that's getting spit out, that's technically Y, is -26. That's showing me a coordinate. First word is whale. Whale. All right, so just real quick, because this is easy to make up one, I'd like you to try this one in blue here, just to show me you're understanding one of these, showing me function notation. Plug in X is -8. All right, rolling on. Next problem. This one is, again, having you plug in 6 into this D spot right here, showing function notation. The cost after 6 days comes from me adding 32 to whatever the product of 18 times that same 6. So that gives me cost after 6 days is 32 plus. Never add before you do that times right there. 18 times 6 gives me 108. Now I could add, gives me C when it's 6, gives me 32 plus 108, which is 140. And again, what that point means, this one a little bit more descriptive, means after 6 days at this place, I have a cost of $140. If I was to graph this, I would have my days on the x-axis, and then I would have on the y-axis my cost. And again, since this is linear, it's going to be a straight line growing at a continuous same rate every time. All right, moving on. Number 3. This one is the function test, which is if you have an input spit out 2 different outputs, not a function. This first one, I'm just going to have you disregard this because, again, that is a function. It's showing that if I plug in n, anytime I'm plugging in a different number, I'm adding 1 to it. So for example here, if I have this function right here, which gives me 3, and I plug in 1 right there, that gives me 3. But if I take this f of n plus 1 and plug in that same 1 right there, what will happen is that gives me the function at 2, which means that changes it, and of course that spit out a different number. That gives me the function at 2 is that 4 number right there. So again, that's showing an input every time a different input. So don't look at that one. The other ones, looking at these, you're looking at these input numbers. If these repeat, good chance that data is not a function. That's showing an input spitting out 2 different outputs. And for this problem, they're having you explain which one is not a function. Explain in a complete sentence. You're going to be typing that out. So know that for these, the only one that has an input showing up more than once is this B set of data right there. So you would just type B that has an input 2 giving me 2 different outputs. That's not a function. Can't have 2 give me a 1 and then that same 2 give me a 3. That's a input spitting out 2 different outputs. What would have made this table be not a function would have been, for example, if I had another maybe 2 right here. And again, that would show me the same 2 spitting out 2 different inputs. That's how a bad table would look. The same input in that column spitting out 2 different outputs. An input-output table right here, for it to break the function rule, would have 2 arrows shooting out of one of these input numbers. That would be showing an input spitting out 2 different outputs. That would be like, oops, that would be a bad arrow, sorry. Let's do an arrow pointing down here to 3. There we go. So that would be breaking the function rule. That would be like 6, 2, and then another 6 spitting out 3. You cannot have that same input give you 2 different outputs. That breaks the function rule. All right, moving on. Number 4, next word is swam. Swam, second secret word. All right, here we go. Increasing, decreasing. These are multiple choice, but I'm just going to have you straight up answer them. So increasing is going uphill from left to right. Decreasing is going downhill from left to right. And you describe those intervals using these x-axis numbers to describe that interval where that data is going from left to right and going uphill. That's where I'm getting these numbers. So that first interval where it's increasing looks like from -5 to -3. And again, always write the low one first. Inequalities always go this direction. And then I have the other inequality that same direction with that -3. That's one of them where it's increasing. My other stretch where my x values are increasing go from that same -3, same inequalities, but this stretch I could see ends right here at -1. That's where I'm getting those values for that interval. Where it's going downhill, I could see it starting at that same -1. Inequalities always go this direction. I could really put those lines under there, but for test's sake, I'm going to leave them out. And then that other boundary is right here at 1. The other one goes from this 3 to this 5. Those are my intervals where it's going downhill, looking at my x-axis numbers. All right, next is maximum, the very highest point. Right here is my maximum written as a coordinate. So that as an xy coordinate normal, left -1, up 4. That is the maximum right there, that highest data point. The lowest data point is right here. There's my minimum written as a coordinate. Right 5 for x, down 3 for y. That is my minimum. 5, -3, the minimum. All right, let's moving on. Number 7. Next random word is up. Up. All right, this problem is multiple choice, but I'm just going to have you write them. Where is it? Describing the range. So range, remember, you got to read it carefully. Range is measured from bottom to top. This problem right here, there is no bottom to it. So there is no bottom to my range. So for my range, I'm going to bottom that out as rounded -infinity because there's no bottom to my range. Up here, 2, 3 on the y-axis. And because that data is included, square bracket has to be just like that. And then just remember, folks, if this problem right here had a solid data point, maybe right here, then my range would be from -3 on the y-axis up here to 3. I would write that square bracket, -3 up to 3 using y-axis. That's the only time I use the y numbers to look. But for this one, since I have that arrow going down to infinity, I'm sorry, going down, yes, that is negative infinity up to 3. The domain is measured left to right, using not the y numbers, but the x numbers. So this -6 square bracket, because that is an included data point. And then the tricky one, arrow looks like it's going downhill, looks like it should be negative infinity, but it's not negative infinity. Domain, like all intervals, measured left to right. So that arrow is going off to the right. So that is positive infinity, always rounded for set notation. All right, moving on. Next word is under. Under. All right, this problem right here has you give the domain for these coordinates. Remember, these are all coordinates. That's the coordinate 2, 10. The domain are the x values. The x values are the domain. Those are the ones you're looking for in that function test. If those x values repeat, good chance that data is not a function. The x values, list those x values for those coordinates. So that's 2. The other x1 is 4. Then I got a 5. And then way over there at 8. If I wanted the range are the y values for that data right there. But this problem is not having you list the range. It's not having you give the complete coordinate. Don't give me the complete coordinate. It wants just the x numbers. All right, moving on. This problem right here, again, pure, just looking at the x numbers, see if they're repeating. If they're repeating, not a function for this. If they're not repeating, it's a function. And again, this one's having you pick one that's not a function. And again, explain in words, complete sentences, that an input is spitting out 2 different outputs. So here we go. That first one, I have my inputs 1. All of those repeat. So that one is not a function. So that 10th problem wants you to select ones that are functions. So read carefully. That one's not a function. So don't select that one. This next one, 3, 4, 5, 6. None of those x numbers are repeating. So that one is a function. Select that one. Number 2. And then the next one, I got -2, 0. 2 is not the same as -2. Oh, another 0. There we go. Spitting out 2 different numbers. Not a function. All right, moving on. -4, 2. 4 is not the same as -4. 3. There's no other 3. That is a function. Select that one. 4 also. All right, next one. 3. -3. Again, that's not the same. 2. Not the same. That's a data set showing a function 2. Select that one. And then, of course, the next problem wants you to select one that's not a function. Like maybe number 1. 1 is not a function. And explain why in a complete sentence. 1 is not a function because the inputs are spitting out more than one output. Or 1 is not a function because the input is showing 2 different outputs. You're going to be writing that in a complete sentence. In a complete sentence. All right, let's move on. Next problem. Number 12 wants you to graph with just the y-intercept and then just the x-intercept. They want 2 points. They want you to place a point. They don't want a point anywhere else. That's not a y-intercept or an x-intercept. So the way I teach this, remember, this -6 right away is one of your first dots. Where you put your first point always goes on the y-axis, and it's always that number that has no x attached to it, or no f of x. Both these have x's in them. That 6 is the only thing without an x. That's your first point. And then for this, to find my other one, because right here I found my y-intercept. Now I look at this number in front of x. I would like you to write that out and know that any whole number you could put over 1. So that tells you from that green dot, your pattern, where you're going, how many boxes you're counting. You're counting over 1 box to the right, down 3. That's where my next point is going to go. I wouldn't write those lines though, but you'll be confused. So write 1, down 3, and then continue that pattern again. Write 1, down 3, write 1, down 3, and you can see write 1, down 3, write 1, down 3. My y-intercept, or I'm sorry, my x-intercept is right there. Make sure on test day that you get rid of this coordinate. Don't have that extra coordinate there. They don't want you to plot that extra coordinate. We want you to plot only the x-intercept and the y-intercept and graph this. So there it is. Draw your line through them. Remember that technically on these lines, let's do a straight line. We want you to draw arrows through your extended line. Don't not draw arrows. That's showing a line segment. So show arrows on those lines. Arrows showing that goes on forever, forever. There we go, right there. That is it. Next word is boat. Boat. All right, moving on. Next problem. This guy right here, words that describe this. So again, now first couple words, continuous, decreasing, discrete. Couple categories, here we go. Let's look at it. Increasing, or how about let's do continuous or discrete. Continuous is a line. That's continuous. If it has just dots like that, that is discrete. So I could see first category, continuous with a line drawn through it, or dots, discrete data. This has a line drawn through it. So again, I could see this is continuous. It's continuous. I wouldn't select discrete. That would be for dots. All right, next category. How about increasing, decreasing, increasing, going uphill? This is the next category. Increasing, is it going uphill from left to right, whether it be curved or straight? Or is it decreasing, going downhill from left to right, whether it be straight or curving? And I could see this one clearly going uphill. That would be increasing, not decreasing. And then my last category, is it exponential? Exponential are those timesing sequences. Exponential gives you curved, you're timesing. Or is it linear, which gives you straight, adding, subtracting? And I could see this is definitely not straight. It's exponential. So those words will describe that line right there. All right, moving on. 14. This one, again, they want you to describe linear. Linear is adding, subtracting, add, subtract, adding or subtracting by the same number, adding, subtracting. Exponential for this problem set, anything you see a percent is timesing, exponential timesing. And then neither percent or adding, subtracting by the same amount. So again, that's a little tricky, the neither one. Here are my categories. Number 1, this one says during the spring, grass is growing 1/3 inch per week. There's no percent symbol there. Adding 1/3, and then another week, adding 1/3. That makes that one a pure linear situation. That's going to be a straight line, adding 1/3 every week. All right, next problem, a little harder. I have $40 for 2 hours, and then I have $90 for 3. For this one, you got to find if it's going up at the same amount, the rate. So here we go. $40 divided by 2 hours. What's that unit rate? That would be $20 for every hour. If I look at that blue, that would be 90 divided by 3 hours. That would give me $30 per hour. And since these are different, these are not the same, I'm going to make sure number 2 goes in this neither. if those would have been the same, for example, if that would have been 60 instead, that would have gave me $20 per hour. Then that would have instead gone into here. That would have been linear if I divided those out and got the same. But sure, on that one, you could see the rate of change for those situations were not the same. That's neither. It's not timesing. You're not changing by the same amount neither. All right, number 3, easy. Soon as you see a percent, that means you're timesing. You're timesing by the part of a whole. This one would be timesing by 1.12 each time. 100%, 1 plus 0.12, timesing by 0.12. That makes this definitely exponential. Number 3 is exponential. Number 4, here we go. Number 4, from 1 hour, looks like this. 1, 4, 2, 9, 3, 15. Look at those rate of change numbers for these up here. See if they're going up by the same amount. This is going up by 5. And then I can see this is going up by 6. That's not the same amount. It's not timesing. So this one would be neither. And then, of course, to know if this would have been going up by the same amount, if this would have been 14 instead, going up 1, 2, 3, that would have been definitely linear. That would have been going up by 5 each time. I would have put that in the linear category right here. But because, again, that's not going up by the same amount, I put that in the neither. And then the last one, again, I have a percent. 1/3% is about 0.33%. 0.3, that would be timesing by 1.3 approximately. That makes that exponential. This one would be curved data eventually, I promise. This one down here would be curved. All right, moving on. Next problem, 15. Looking at data. Next word is then. All right, looking at this, from -59 to -42, it looks like I have to be adding a number right there. To make something negative go down, I'm adding. So if I don't know what that is, just take plain 59 minus 42. That will tell you 17. That means I'm adding by 17. That's the only thing that makes this number whittle down to -42. So that means I'm adding. Anything that's adding is an arithmetic sequence. So that's adding, subtracting, sequence A. The next one here is not adding, subtracting. Looks like 384 to 192. I'm not timesing. Looks like I'm dividing. That's what it looks like. Looks like I'm dividing by 2. But remember, for sequences, we don't show dividing by 2. We show dividing by 2 is the same as timesing by 1/2. So those look like I'm halving them. I'm timesing each by 1/2, which is the same as dividing by 2. 12 times 1/2 is 6. Divided by 2, that's the same thing. And of course, since I'm timesing, that makes this one geometric. And again, arithmetic is, again, another word for a linear straight line. Those geometrics, those are the exponential ones. Curved. All right, moving on. Here we go. 16. This one, which has the domain 3 going off to the right, positive infinity, starting at 3 on the x-axis. I'm looking at this one, but because that data circle's open there, that wouldn't be right. This would be rounded 3, positive infinity, and that doesn't match what I'm looking for. This one right here is definitely square bracket on that 3, but be careful. People on this one think that's negative infinity, and they're like, oh, that's not true, but you got faked out. Yes, that is positive infinity because this is going off to the right. I don't care it's going down. That's being measured left to right. That's going to the right. That is positive infinity. That one for sure works. Don't be faked out by that one. All right, this guy right here is going off to the left. So this one would actually be rounded negative infinity to 3 square. And you can see that's backwards. And then my last one, this one, of course, I could see starts from 3 square. And then clearly that arrow is going off to the right. So that one is the second one that applies. All right, rolling on here. 17. All right, this one, I want you to solve this literal equation for the variable g. So my advice is to take this equation and flip it around. I'm telling you, the people who are most successful, they're going to flip that equation around just like that. And now you're solving for this g right there. So I would flip it around. That has you take this 85 away from p. Cannot subtract 85 from p. So I'm going to just write that as 5g equal p. I'm going to write that p first, minus 85. And then my next step, opposite of timesing by 5, I'm dividing everything over here by 5. Both parts I'm dividing on this right side by 5, dividing that p by 5 and that negative 85 by 5. These will go away and leave me that g that I'm trying to solve, number of guests. That is p over 5. And then I'm going to use my calculator, leaving that negative. 85 divided by 5 gives me minus 17. All right, I'd like you to try one of those for sure. Here's your P. Here's your G number. And then here is your other number. Solve that for G. Practice one of those. All right, next problem and next secret word is jumped. Jumped. All right, this one right here, which has it solved already and has you write and describe the steps. So right here, I could see that first step to get this, and I'll show you how they get this negative 6x and 9. They get that by distributing. They're distributing this negative 3/4 right there. And again, when you're doing that, that's kind of tricky. You could either just do it straight up and at that point get negative 24x over 4, and then the other side get positive 36 over 4, which shows you when you distribute, you're left with 12x minus, and then that 4 goes in that goes, let's see, did I do that right? Yep, that's going to give me minus 6x, yep, and then right there I have my plus 9. That's one way you could look at it, distributing straight up. Another way you could do that, distributing, is to know that you could cross cancel. I could cross cancel this 4 and go into this twice and then multiply those to get negative 6x, and then cross cancel that 4, go into this 12 3 times, and then negative 3 times negative 3, get positive 9. You could do it that way. But no matter what, that first step is distributive property, distributive property. All right, next, I'm looking at 12x minus 16x. Looks like to get, I'm going to get here by combining like terms. That 12x, and let's keep going right here. Let's do this in red. Now I have 21 equals 12x. Next step, combining like terms to get that 6x. I'm combining like terms right there, combining like terms. And then next, looks like I'm subtracting this 9 on both sides, minus 9 on both sides. That is going to give me 21 minus 9, which is 12, equals 6x. That's going to be a subtraction property. I subtracted equally on both sides, subtraction. And then right there, looks like to get that 2, dividing by 6. That's my next inverse operation. Gives me positive 2, and that is the division property. So again, that's showing that. super duper tough, I would like you on your paper, just show me a distribute brutal one right here. If I give you the brutal fraction 5/6 and you're distributing that times 12x and distributing that times -18, I want you to practice distributing that. And again, I could show you on the calculator, or I could show you those basic parts. Know how to distribute that. Distribute that. All right, moving on. 19, another problem. Here we go. This one has you distribute and then solve. So I'm distributing this -6. Distribute first. That's going to give me -18x, +12 right there. And then bring down everything else. And then right there, next, combine your like terms. Don't be doing any inverse operations yet. Don't do that. Combine like terms first. Get it to inverse operation variables on both sides. Look, this gives me -8x. Know your positive negatives. Use the tools if you need it. Plus that 12 still. -6x plus 6. Please get it to this variables in both sides look, because once you get it there, you're starting by getting rid of this 12, and then you're going to go to the right and get rid of 6x, and then back to the left, divide, stair step it. So here we go. Start on the left, get rid of that plain 12 by subtracting 12 to both numbers. Those go away. Bring down that -8x, bring down your equal, bring down that -6x. This gives me -6. Stay on that side and do the opposite of that, subtracting 6x, adding 6x, knowing that those cancel. And this over here gives me -2x. Bring down your equal, bring down your -6. Last step involves something finally different than adding, subtracting, dividing. Divide by -2, and that gives me the whole number x equals 3. 3 is going to go right here. All right, moving on. And again, for that one, I'd like you to try one. Let's see if I could make one up. Let's say -5 times 2x minus 3. I'd like you to distribute that, knowing your negative rules. And then that's going to be plus 3x. Let's make it like that. Plus 3x. And then over here, let's say -2x plus 9. How about that? Try that. All right, moving on. Next problem. 20. For this one, I want you to solve it and give me 3 solutions. Next secret word is over. Thanks for listening. All right, for this one, add 4 to both sides. Bring down this 3x. Bring down your inequality. Don't put an equal in there. Don't put an equal in there. It's not an equal. It's not an equation. Inequality. This is the less than direction. Less. If it's like this, that is more than direction. So know your inequalities. 3x less than that 18 right there. And then divide by 3. And that tells me this inequality is showing all answers less than 6. Numbers less than 6. If you don't know numbers less than 6, number line it. Draw a number line. Get it right. Don't pick numbers not less than 6. 3 numbers less than 6. Not using 6 would be like 3, 4, 5. Those are 3 numbers clearly less than 6. Notice 6 isn't in there. If I had less than or equal to, then I could put 6 in the match or the batch, but I can't. All right, moving on. 21, this one, the data switch. Looking at this data table here. Starting pattern. Looks like going low to high. Low, -3 is lower than +5. And then, switch. Now, 5 positive is lower than 3. That's the first data switch right there. And then let's keep moving on. Let's see that pattern. Now it's still higher on this column, lower on this column. It's still, even though this is tricky, -1 is still higher than -3. But here's a switch. -3 is not higher than -1. Know your negative rules. Tricky. And then again, that pattern continues. Lower, higher. Know your higher, lower numbers with positive and negative numbers. Tricky. The lower the negative number, the higher the value. The higher the negative value, the lower. So this gives me numbers to use to describe where that switch happened, where this is going to be intersecting lines. So that starts from -2, inequality x, inequality -1, and then the other one from 1, inequality x, inequality 2. All right, next word is flying, flying. All right, last problem, here we go, and last word, 22, graph. Gonna graph the one in blue, starting at -7 on this y-axis, -7 right here. And then looking at that number in front of x, which there is no number, we assume you know that's a +1. +1 written as a fraction over 1, which tells me from that -7, every time I go right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1. Keep going, keep going. Be able to stair step always opposite way. Draw your line. Do this one technical. Draw your arrows. Like you to label that line. Make sure your line is precise. Use a straight edge if you need to. Because sometimes if your line's not precise, if I can get that line there, then it doesn't show where your line is intersecting very well. So let's try to get that line precise best I can. All right, looks pretty good. All right, next one. Starting at -1 on the x-axis, but then looking at this number in front of x, that's tricky. That negative right there really is -1. This one has a slope of -1x. That made into a fraction is over that same 1, but this one tells me every time I go over that same box to the right, then I'm going down 1 because of that negative right there. So my red line starting at -1, right 1, down 1, 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 stair step, always the opposite direction. You can't just be stuck going just one direction. Be able to stair step along that same line, opposite direction. Draw that line best you can. Use a straight edge if you need to. Put arrows on the end showing that goes forever. Label that line because I have more than one line on one graph. It's helpful to label them. And then know that I want that solution point. They're going to have you plot that point. They want you to plot that point. Plot that point. If you plot all these points, probably will give that to you, even though the question wants you to plot only that point. So those people really listening to me, my real listeners, really what you're going to be doing is only plotting that point, only on your graph that they're going to be having you, only plotting that point. Let's see if I could delete some of these points right here. Yep, I can. Only plot that point. People who are really listening to me, they're not going to put all those dots. They're going to delete those dots and only have that one dot there. Only have the solution dot. And again, be patient with me as I try to delete these dots like some people are going to do who are really listening. All right, there it is. Oh, there's some dots down here. Let's get rid of those dots up here. All right, there we go. Now there's no dots. The only dot is this solution dot. And again, that coordinate for x and y, as I go right to the right 3, I'm going down -4. Be able to give me that coordinate. Last word is fish. Fish. And then, of course, the last problem to try, I would like you to graph these two. I'd like you to graph f of x equals, let's go 1x plus, oh, let's not go 1x plus, let's go 1x minus 5. And then the other one, let's say g of x, let's have you graph -x plus 1. Let's have you do that. Looks like I'm shifting those up 2 boxes up that y-axis. All right, graph that. Last problem. All right, good luck. Talk to you in a bit if you're in my class.